Obtain the volume of rectangular boxes with the following length, breadth, and height respectively. So assume that this is our rectangular box, and in this first case the length is 5a. The length is 5a. Excuse me. Breadth is 3a squared. 3a squared, and height is 7 raised to 7a raised to the power of 4. Okay, now all these are monomials, algebraic expressions. So we know that the formula to calculate the volume of a rectangular box is length multiplied by breadth multiplied by height. Now what's length? Length is 5a multiplied by, what's breadth? Breadth is 3a squared, and what's height? Height is 7 raised to 7 multiplied by a raised to power of 4. From here, this 5 of this monomial, 3 of this monomial, and 7 of this monomial, group them together and multiply. Then this a here, this a squared here, and a raised to the power of 4. So a squared, a raised to the power of 4. Group them together and multiply. So this is 5 times 3 is 15 times 4 is 60, multiplied by a multiplied by a squared multiplied by a raised to the power of 4. Now this is a, 1 plus 2 plus 4, that is a raised to the power of 7. So this is a raised to the power of 7. This can be written as 60a raised to the power of 7. Right? Let's take the next one. Now in the second case, we have length as xy, breadth as 2x squared y, and height as 2xy squared. So putting this in this formula, length is xy, breadth is 2x squared y, multiplied by height is 2xy squared. Now if you look here, you have 2 here, you have 2 here, but you don't have any numerical number, you don't have any numerical coefficient in this case, right? But no, there is. Whenever there is no numerical coefficient written, always think of 1 here, right? So this is 1. Now this will be 1 multiplied by 2 multiplied by 2. Next, multiplied by this x here, this x squared here, and this x here. So x multiplied by x squared multiplied by x, and then multiplied by this y, and this y squared. So this is y multiplied by y squared. Now if you solve it, you'll get 4 multiplied by x, 1 plus 2 plus 1, that's, and multiplied by y raised to the power of 1 plus 2. This is 4 x raised to the power of 4 multiplied by y raised to the power of 4. This can be written as 4x raised to the power of 4 y raised to the power of 4. This is your answer, right? Now the third case. In the third case, you have length is a, breadth is 2b, and height is 3c. From here, if you put these values here, a multiplied by 2b multiplied by 3c. Again, since you don't have any integer here, so numerical coefficient here, right? 1 here, right? So now 1, 2 and 3, group them together. So 1 multiplied by 2 multiplied by 3 and multiplied by, you have a only here, right? No other monomial, like from these, if you look at these two, they don't contain a, so write a, multiplied by, similarly write b, similarly c. This is 3 times 2 is 6, a, b, c. Okay, now let's move to the next flow. Obtain the product of xy, yz, zx. So here you have to multiply 3 monomials. Let's assume that the monomial 1 is m1, denoted by m1 is xy, m2 is yz, and m3 is zx. Now you have to find m1 multiplied by m2 multiplied by m3. This can be written as xy, yz, and zx. So this xy can be written as x multiplied by y. This yz can be written as y multiplied by z, and this zx can be written as z multiplied by x. Now, since we don't have any numerical coefficient in in these 3 monomials, it means that they are 1. So 1 multiplied by 1 multiplied by 1 will be 1. So we don't have to think of the ones. Now you have to look at the variables. You have x here and you have x here. So x multiplied by x. Now you have y here, you have y here. So multiplied by y multiplied by y. Then you have z here and you have z here. So this is z multiplied by z. So this gives you x squared multiplied by y squared multiplied by z squared. This can be written as x squared, y squared, and z squared. So this is your answer. Now let's move to the next part. And here you have a minus a squared and a cubed. So m1 multiplied by m2 multiplied by m3 is a multiplied by minus a squared multiplied by a cubed. Okay, now this is minus, right? You can simply write this. None of these monomials contain any numerical coefficient. That is, it is actually 1, right? So you can think of this minus a as a multiplied by minus 1a squared, right, multiplied by a cubed. Now this is 1a, this is minus 1, this is 1a cubed. You can write it as this is 1, this is minus 1, this is 1. So 1 multiplied by minus 1 multiplied by 1, right? Then you have a squared and a cubed. So a multiplied by a squared multiplied by a cubed. If you solve it, you get minus 1 multiplied by a 1 plus 2 plus 3. So this is minus 1 multiplied by a raised to power of 6. This can be written as minus a raised to power of 6. Okay, so this is your answer. Now next you have in this case you have now 4 monomials. So let's say that you have here m4. Now this m4 is 2, 4y, 8y squared, and 16y cubed, right? In this case you have to find m1 multiplied by m2 multiplied by m3 and multiplied by m4. This is 2 multiplied by 4y multiplied by 8y squared multiplied by 16y cubed. Okay, now this is just 2. is any numerical number, is any integer a monomial or polynomial? Yes, because this 2 can be written as x raised to the power of 0. It can be written as 2 y raised to the power of 0. Why? Because x, any variable raised to the power of 0 means 1. So it's actually 2 multiplied by 1. That is why we say that an integer is also a polynomial or monomial. Monomials are a type of polynomials. Okay, so in this case, this is monomial 1, 2, this is 4, this is 8, this is 16. So you write it as 2 multiplied by 4 multiplied by 8 multiplied by 16, right? And then multiplied by, you have y here, you have y squared here, you have y cubed here. So this is y multiplied by y squared multiplied by y cubed. This is now 4 times 2 is 8 multiplied by, this is 8 times 6, 48, and 4, 128, and this is y 1 plus 2 plus 3. Okay, this 8 times 128 can be written as 8 times 8 is 64, 6, 8 to 16, 22, 8, 1 and 10, multiplied by y raised to the power of 6, 1024 y raised to the power of 6. Now, here you just have 3 monomials. So remove this m4, and now this m1 is m, this is minus mn, this is mnp. So if you multiply it, you get m multiplied by minus mn, this is minus mn multiplied by mnp, right? This can be written as 1m multiplied by minus 1 mn multiplied by mnp. Now 1 here, this is 1, this is minus 1, this is 1, so 1 multiplied by minus 1 multiplied by 1 multiplied by, you have m here, you have m here, you have m here. So this is m multiplied by m multiplied by m. Then you have n here, you have n here, and then you have p here. This is minus 1 multiplied by m cubed multiplied by n squared multiplied by p. Now this can be written as minus m cubed n squared and p. So this is your answer.